Okay, assalamualaikum and hi guys. So in this video I'll explain on how to solve the IVP and BVP using Laplace transform. So IVP is the initial value problem and BVP is the boundary value problem. Do you still remember? If initial you have let's say y0 equals to 1, okay, if you have only one value here, then it is initial value. Then if you have y, for example y3 equals to 4, so if you have two values now, it is BVP, boundary value. Okay, so in this section we will see the use of Laplace transform to solve differential equation that have been discussed earlier in chapter 1 and chapter 2. So if you still remember, our aim or our objective of this course is to solve the differential equation. So in chapter 1 you have learned how to solve the differential equation by using first order linear ODEs, the second order linear ODEs. Okay, so in this chapter you have learned the Laplace transform, meaning that in this subtopic, solving the IVP and BVP using Laplace transform, in this subtopics you will learn how to solve the DEs by using Laplace transform. Okay, so to solve by the DEs by using Laplace transform, we will go through 4 stages. One is you rewrite the equation in Laplace transform. The second, you insert the given initial condition, and then you rearrange until you get ys. Okay, and then determine the inverse transform. So at the end you will need to find yt. So to find yt you need to have the inverse of Laplace transform of ys. Okay, so basically it's like you have a differential equation, and then this is the Laplace transform. Let's say this is an approach. Okay, so you substitute your equation in this Laplace transform, and after you substitute, then you will have the Laplace transform and the inverse Laplace, and then for the output you will have the yt. So basically it's like that. Okay, so this is the transform of derivative. So if you still remember, our definition for Laplace transform is the Laplace transform of ft is equals to fs, right? Okay, ft is equals to fs. So if you have yt, then it is equals to ys. Okay, the Laplace transform of yt is equals to ys. So the Laplace transform of the first derivative of yt is equals to sys minus y naught. Okay, now you have 1, the power is 1 here, and then here s is the power of 1. Okay, now y double prime, the second derivative of yt. Okay, now you have 2 double prime here, so you will start with s2. Okay, s2 ys minus sy naught minus s prime naught. Okay, if you have y triple prime, so you will start with s3, s cube. Okay, s cube ys still ys for all, and then minus s square. The s will reduce by 1. Okay, the power of s will reduce by 1, so you can see here it's s cube, then s square, then s. So here should be suppose is s power 0, so s power 0 is 1, right? So for the ys you will start with ys, and then the second term is y naught, then it will be y prime naught, y double prime naught. It's like that. Okay, so I hope that you can remember this transform of derivative, because we will use it later. Okay, so now example 23. So we'll go to example 23 now. Solve the equation of dy over dt minus 2y equals to 4, given that t equals to 0, y equals to 1. So from this condition you have y0 equals to 1. because when t is equals to 0, y is equals to 1. Okay, so for the first step, you rewrite this equation in Laplace form. Okay, so this is equals to the Laplace of y prime, because this is dy over dt, right? Dy over dt is y prime. So Laplace of y prime minus 2 Laplace of y equals to the Laplace of 4. Okay, so now you substitute this with the transform of derivative just now. This is y prime, so we have s power 1 here, so ys minus y 0. Okay, minus we have 2 for y, the Laplace of y is equals to ys. Okay, the Laplace of ft equals to fs. The Laplace of y t equals to ys. Okay, so y and yt is the same, so now is equals to the Laplace of 4 is equals to 4 over s. This 4 over s I get from the table. Laplace transform of constant is the constant over s. Okay, the first step. The second step is to substitute the values of IVP and BVP into your equation. So s minus y naught, y0 is equals to 1. Y0 is equals to 1. So this y0 is equals to 1 minus 2ys equals to 4 over s. Okay, the third step. Okay, the third step, we combine all with ys on the left hand side and those without ys on the right hand side. So we have s minus 2 here, ys equals to 4 over s plus 1. Okay, so here it is 4 plus s over s. So ys equals to 4 plus s over s. So this s minus 2 you bring to this side, you will get s minus 2 at the denominator. So you have now ys. Okay, the last step is to find your yt. So yt is equals to inverse Laplace. Okay, inverse Laplace of the ys. Okay, so inverse Laplace of 4 plus s over s minus 2. Okay, so the inverse Laplace for this fraction, you need to do the partial fraction. Okay, for this fraction you have to do partial fraction to simplify the fraction. Okay, so I'm not going to show you how to do partial fraction. So I bet you know already how to do partial fraction. So please make sure that you know how to do partial fraction. Okay, so from this fraction you will get negative 2 over s plus 3 over s minus 2 from the partial fraction. Okay, so now you can do the inverse Laplace. So the inverse Laplace of negative 2 over s is negative 2 plus this is 3 the inverse Laplace of 1 over s minus 2 is e to the power of 2t. Okay, so this is the final answer, the final solution for the given differential equation. So yt equals to negative 2 plus 3 e to the power of 2t, right? Okay, now let's go to the next example. Example 24. Solve the equation d square y over dt square minus 3 dy over dt plus 2y equals to 2e to the power of 3t, given that y0 equals to 5 and y prime 0 equals to 7. So firstly, the first step is to rewrite your equation in Laplace form. Okay, so Laplace of this is y double prime minus 3, this is the Laplace of y prime plus 2, the Laplace of y equals to 2 Laplace of e3t. Okay, then you have to do the transform of derivative. Transform of derivative for here, for y double prime, so your s starts from s square because this is double prime. Okay, square, so s square ys minus s, because the power will reduce by 1, right? So s square here will be s, so s, so you will start with y0 minus y prime 0. Okay, this is for the first one. For the second term, minus 3, okay, y prime, for y prime, so your s is power 1, s minus y0. Okay, for the third term, plus 2, this is just ys, because the Laplace of y is equals to ys, equals to 2, the Laplace of e to the power of 3t is equals to 1 over s minus 3. So this is the first step. The second step is to substitute the value of IVP and BVP into your equation. So from your equation here, s square ys minus s y0 is equals to 5 minus y prime 0 equals to 7 from here, minus 3 sys plus 3 y0 equals to 5 plus 2ys equals to 2 over s minus 3. Okay, you already substitute. Next, okay, those with ys we put it on the left hand side, and without ys we put it on the right hand side. So we have here s square minus 3s and then plus 2 ys equals to 2 over s minus 3. Here is negative 5s, so here it should be plus 5s plus 7 minus 15. Okay, so this is equals to, okay, this one you factorize for this part. Okay, you factorize this one, you will get s minus 1 s minus 2 ys equals to, this is 2 plus, okay, this one should be 5s minus 8 here should be times s minus 3 over s minus 3. Okay, then you find what is ys. So ys is equals to 2 plus, okay, this one you expand because later we're gonna simplify the function. Okay, so you have 5s square minus 15s minus 8s plus 24 over s minus 3 s minus 1 s minus 2. Okay, so now ys is equals to, okay, you simplify, at the end you will get 5s minus 13 s minus 2 s minus 3 s minus 1 s minus 2. Okay, so you can cancel, you just have 5s minus 13 over s minus 3 s minus 1. Okay, so this is the third step, the fourth step, the last step, to find yt. Find yt after you get ys. Okay, so yt is equals to inverse Laplace of ys, equals to inverse Laplace of 5s minus 13 over s minus 3 s minus 1. Okay, so from here, to do the inverse Laplace, we have to use partial fraction once again. Partial fraction. Okay, so by using partial fraction, you get 1 over s minus 3 plus 4 over s minus 1. Okay, so the inverse Laplace of 1 over s minus 3 is equals to e to the power of 3t plus, this is 4, okay, 4, e to the power of s minus 1 is t. So this is the final solution for the given DEs, okay, by using Laplace transform. Right. So now you have passed your final exam. As usual, I want you to do the assignment 3.6. Assignment 3.6. Okay, assignment 3.6 and submit in e-learning as usual. Alright, so you have 1 question, 2, 3 and 4 question altogether. Alright, so that's all for this video. I hope that you can understand how to solve the IVP and BVP using Laplace transform. Okay, so see you in the next video. Thank you.